Time ticks, okay? And the last little thing, compass error by terrestrial range. What time is it? Historically, the chronometers were analog watches, analog clocks, okay? And it turns out, though, that, now we have like very, very good watches, but it used to be that you had to listen to a time tick. Have any of you ever heard a time tick before? Okay, a few of you have. So you would tune in on the single sideband, okay, and there were radio stations around the world that were broadcasting the official time in UTC. So that's the time. That was the top. That was like the beginning of a minute, right? Oh, mute me. So in about one, so that's a second. And you would listen on the radio, various frequencies, and then you would basically use that to figure out how the chronometer in your bridge, what the error was. Okay? So there are 3 different clocks on the ship. There is the time that's coming, the official time that's coming over the radio that was in the radio room. These problems are based on this technology, okay? I'm sorry. So, and then there was a clock in the bridge, a different part of the ship that was a clock like that one up there, okay? And so you had to get the time.
0 hours, 43 minutes, coordinated universal time.
Okay? So that beep is the beginning of that minute, okay? And every minute of every hour they chime off and they say that. So I have to take a time that I get from my radio, and then I have to walk to the bridge. So this is a clock, and on the bridge there's a chronometer. All right, and it could be that the radio room is way the hell back there and the bridge is way up there. So I have to go from my first clock, which is a radio signal, to my third clock, which was on the bridge. So that means I need a timepiece to walk from one to the other. And that was now, you would use either a stopwatch or a comparing watch. So in these problems, there are 3 different timepieces, and you've got to figure out which timepiece is doing what. Okay? So you would take the second timepiece and you would walk to the third timepiece. You would use the second timepiece to transition from the first to the third. Okay, so there's a whole bunch of terms in here: chronometer, chronometer error, comparing watch, rating the chronometer, and the time tick itself. All right, 3 different timepieces: the chronometer, the comparing watch or the stopwatch, and then the time, the official time, the time tick itself. Okay, so great. So if you want to learn more about time ticks, you can go into Pub 117 and read all about them. So let's just do this problem. We're going to do 2 different styles of problems. Okay? You are taking a time tick using the 12 o'clock signal from Valparaiso, Chile. What time is it according to that time signal in this problem? It's noon. At the tone, the time will be 1200 hours, coordinated universal time. So you hear a series of 1-second dashes. You heard those. Followed by a silent period and then a 1.3 second dash. At the beginning of the long dash, that's when it was officially noon and GMT, transmitted from the Valparaiso station. At the beginning of the long dash, your comparing watch, a watch that might be on your arm, reads 12:00:18. What time is it actually on the world standard? Noon. What time does the comparing watch say? 12:00:18. What does that mean about the comparing watch? It's 18 seconds fast. Watch 1 is noon. Watch 2 is 18 seconds faster than watch 1. Now I'm going to walk to the bridge. Okay? So I have UTC from the radio room, that's noon, and I have my comparing watch, which is 18 minutes fast. So, and I have my chronometer on the bridge. So UTC is 12, my comparing watch is 12:18, which means my comparing watch is 18 minutes fast. Okay? 18 seconds. Thank you. Okay? Yeah. So now, 18 seconds. So then what happens? When compared to the chronometer, what does that mean? When compared to the chronometer, what does that mean? It means you walked to the freaking bridge and then you looked. You looked at the comparing watch and you looked at the chronometer. So the chronometer, the comparing watch reads 12:01:23. And the chronometer reads 11:59:35. What is the chronometer error?
1 minute, 22 seconds.
Well, so first of all, how long did it take you to walk to the bridge? And does it really matter though?
No.
It doesn't matter. You could do the math for it, but it doesn't matter. Okay, it took you it took you 1 minute and 5 seconds to walk to the bridge, but it doesn't matter. What matters is when you got to the bridge, what is the difference between the comparing watch and the chronometer? But what do we have to do to the comparing watch first? We got to subtract 18 seconds. Once I get to the bridge and I look at both of them, okay, I can subtract 18 seconds, and what does that give me? That gives me the time of GMT on the bridge at that moment. So if my comparing watch when I get to the bridge is 12:01:23, if I subtract 18 seconds from it, then it is 12:01:05 UTC on the bridge at that moment. Now I compare that to the chronometer. What was the chronometer at that moment that I looked up there? 11:59:35. What's the difference? It's 1 minute and 30 seconds slow. Okay? Okay. So now we're going to do it. There's two types of problems. There's that one, and then there's this one. So this one is about gaining and losing. This is called rating the chronometer. So let me just explain what this, so this is supposed to be like GMT time. And then if your watch is on this side, it's faster than GMT. And if your watch is on this side, it's slower than GMT. You get that idea? So here is like a comparing watch. Okay? Now, if it's running fast, it's on that side. And if it's running slow, it's on that side. Okay? But the thing I want you to realize is, okay? The thing I want you to kind of realize here is, right now, it's running fast, but every second, oh, scheisse. It's running fast, but every second it's running a little bit faster. What is it doing? Is it getting closer to the correct time or farther away? That's called losing. It's running fast, but each moment it's running even faster. It means it's getting more wrong. Therefore, it's losing. So going away from correct time is losing. What happens when I get to here? Well, it's still running fast, but what's it doing from moment to moment? What's it doing? It's getting closer to the right time, therefore it's gaining. Okay. Right there, it's on, there's no error. What's going to happen as it goes to the other side? It's getting more wrong, therefore it is losing. And now it's slow, but it's getting better, so it is gaining, okay? So you've got to keep that concept in mind when we do this problem. All right? You got to keep that concept in mind when we do this problem. July 3rd, you take a time tick at the 0900 GMT Cape Town broadcast. You hear a repeating series of 59 dots followed by a dash. That's kind of just in there as a distractor. At the beginning of the 5th dash, you start your stopwatch. So now you're not using a comparing watch, you're using a stopwatch. The chronometer reads 08:39:16 at the time the stopwatch reads 1 minute and 42 seconds. The chronometer error at yesterday was 22 minutes, 24 seconds slow. What is the chronometer rate? So they want to know is what's the change from day to day? Okay, so it's 900 UTC. Okay? And 1 minute and 42 seconds later, we walk to the bridge. So what time is it in UTC? 0914 UTC. At that point, what do? We look at the chronometer. What does the chronometer say? 083916. So it's really 090142 in the real world, but my chronometer is that, so I get my error. And my error is 22 minutes and 26 seconds. Back in the day, you didn't reset the chronometer. You just kept recording the error each day. Okay? So what is the error today? It's 22 minutes, 26 seconds. What was the error yesterday? Okay. So it's slow today. So it's 22:26. Yesterday it was 22:24. What's the difference between yesterday and today? 2 seconds. Is it getting more wrong or is it getting less wrong between yesterday and today? More wrong. So therefore it is losing. That's how you do that problem. Those are the two types of time tick problems.
This test 5, is it going to be over all this miscellaneous stuff?
Yes, all at once.
Okay, and not the other stuff that we're doing right now.
Not the other stuff. The tides and the current stuff is on Thursday. This is next Thursday. Okay. Oh, we don't even worry about that. All right. So one more to go.